Hello, and welcome to today's webcast, ANOVA Regression and Partition Trees. My name is Pawnee Allen, and I will be hosting today's webcast. We would like to answer questions that arise during the broadcast, so please use the chat or Q&A panels to submit your questions at any time. However, we will wait until the end of the presentation to address your questions. Let's meet our presenter. Kevin Potzner is an academic ambassador with JMP. JMP is a business unit of SAS specializing in desktop software for dynamic data visualization and analysis. Now we invite you to sit back and relax, and we'll go ahead and get started.
All right, thank you very much, Pawnee. You can hear me?
Yep, I can hear you great.
Okay, perfect. All right, well, thanks everybody for joining today's session and also, coordinating whatever you have to do in your lives. I know it's not easy for all of us what's happening right now, so I hope everybody is safe and healthy. All right, so let's jump into today's session. So we're going to be covering regression and ANOVA techniques, and at the end I'm also going to cover partitioning methods that JMP does. So the best way to do it is to analyze the data set and show you the tools and show you how JMP handles it. Okay, so this is a data set, and we don't have to get super detailed, but it's a pharmaceutical manufacturing process. And we have 90 measurements, and I can see that here with this number 90 in the lower left corner. So there's 90 rows. I have 20 variables or 20 columns, and you can see this over here in the middle panel on the left. Two of these variables are basically the dissolution value, which this is going to be the outcome value of interest. And there's a specification that the dissolution values are greater than 70. We also have a column that sort of just turns that into a binary accept or reject if it meets that requirement. There's a variable we're not going to need, which is just an ID. But basically, you'll see we have 17 different candidate explanatory variables, right? So yeah, we're not going to get into all the details, but the thing I want you to notice is that some of the variables are categorical, some of them are continuous, but we've got 17 different variables that have to do with this manufacturing process, right? Things like blend time and blend speed and different categories of suppliers, right? So you can kind of see all those. Now, JMP has a really neat way to quickly get a view of that data. Up in the upper left of the data table, there's this little mini icon that's a histogram, and if I click on that, it opens up a little display at the top of each column, which shows me a histogram if it's a continuous variable with the min and the max shown. So I can see for dissolution, the minimum value I have is 64.2, and the maximum value is 80.2. And then I have categorical variables, and so you can see, for example, this thing called API particle size. You can see that there's 3 levels: medium, small, and large. And you'll notice that when I click anything in these little diagrams, it actually highlights that data. So this is an easy way, for example, if I wanted to exclude one of, like, say, the small particle sizes from this analysis, I can click on it and say, hey, don't include this in the analysis. Now, we're going to include all of the data, but just wanted to point out that these things are actually interactive, these little graphs at the top. It allows you to kind of select specific rows in the data table. Okay, so that's kind of a quick way to see it, but I like to pull up another tool in JMP, which gives me a bigger view of those histograms and also gives me some more summary statistics. So under the Analyze menu, the first item is this tool called Distribution. And basically what you do is you put the variables in. Now I don't know if you're noticing this, but I actually have the variables grouped over here. So I've got my 2 Y's and all my X's. So you can do that. I find that's a little bit easier when you have your work a little organized. So that's why when I pull up a dialog box, it's in those groups. And if I want to select specific ones, I can open them up. If I want to grab them all, then I can just do that, and a little bit bigger so you can actually see them all. And so all the variables are sitting right there. And I hit OK. So what JMP is going to do is, for a variable that's continuous, like this dissolution value, it's going to make a histogram, and it's going to show me a bunch of summary statistics. And you can change those if you want. You can click on these little red triangles. And you'll notice that everywhere in JMP, there's a little red triangle that if you click on it, it brings up other options. So this would allow me to, for example, change the summary statistics to something else. Now, I have in that variable dissolution, I have specified that there's a lower spec limit of 70. And if you do that, something that JMP will do automatically is, in addition to drawing the line on the graph, it actually, as you see over here, runs something called the capability analysis. So those of you who are familiar with that quality Six Sigma world, this is a big thing used in manufacturing because you want to estimate what percentage of this process meets specification. And we can see this is large percentage here that do not meet that specification. And that's a concern. That's why we're going to be doing this analysis, is to see if we can find out variables that impact that. Now, if we scroll down, when you see a categorical variable like lot acceptance or AP particle size, then JMP makes a bar chart and shows you some counts and frequency. Now, just like those little diagrams I showed at the beginning, these are interactive. So I can, for example, click on something like, I'm going to click on reject. And if I look at all of these other histograms and bar charts, it will show me all of that data and where it occurs in those other charts. Okay, so that's kind of a quick way sometimes to explore the data. Not the best way here because we have so many variables that it's going to be easier if we use like a formal modeling technique like ANOVA and regression. But I just wanted to point out that this allows you to kind of interact with it and click on an area. And in doing so, we might actually see how these variables are related to the dissolution values, accepting or rejecting. Now I'm gonna save this to the data table. This is something you do in JMP. You click on this top red triangle, you'll see Save Script to Data Table. I give it a name, and if I hit OK, I already have it saved, so I'm not going to do that. It saves it to the data table, and this is what I named it. So whenever I want to see it again, I just click on the green triangle, and it launches it. Okay. So it allows you to sort of create some output and save it, and then close it, so you don't always have to have it in view until you want to. Okay, so let's start building some graphs as a way to explore what's going on, some possible relationships. So the way you make a jump in graph, a graph in JMP, is you pull up this tool called the Graph Builder. And I really like the way JMP does this. Other software doesn't quite do it like this, and I think this is a nice interactive dynamic way to build graphs. So when you launch this Graph Builder tool, think of this as a blank canvas waiting for you to build the graph, okay? And so I'm going to drag variables into different roles and choose different ways I want it displayed. So I'm going to put dissolution on the y-axis. Now there's only one variable, so it's going to just make a dot plot. Now I can change that. So if I wanted to see, for example, a box plot, I could click on a box plot. If I wanted that to be a histogram, I could click on it as a histogram. And I can move these around. I can drag them. I can even rescale them if I want. I can actually click on it and say put it on the log scale. So there's a lot of options you can do. So think of this as an interactive graphical environment. I'm going to bring it back to the dots. Oh, you can even have multiple things, like the dot and the box plots. Okay. But what I'm going to do, actually, I'm going to click on that too. I'm going to put the mean and the confidence interval. So that's sort of what I just displayed there. Now, I want to see how dissolution changes with the different candidate explanatory variables. So I'm going to drag some of them into the x-axis. So I'm going to start off with this first one, AP particle size. I'm going to put it there. Now, there are 3 levels of AP particle size, large, medium, and small. So JMP says, okay, I'm going to make a comparative. In this case, you have dot plot with the confidence interval. And again, if you change your mind and say, I want to make box plots instead, then just click and make them the box plots, right? So you can go back and forth to the ways you want this data displayed, which I think is nice. So you don't have to figure out everything at the beginning. You can kind of interactively play with this to get the graph you want. Now, remember, I've got 17 candidate explanatory variables over here. Okay, so I just have only one displayed. Well, JMP allows this really creative way where I can swap out the variable on one of the axes, and I'm going to swap out the variable on the x-axis, and I'm going to swap it out with all of the other x's, okay? So now what I can do is over here on the left, I can just click on whatever variable I want to see on the x-axis, okay? So here's meal time, here's screen size, here's this supplier, lactose supplier, sugar supplier. I can even hit a play button, and I'm going to let it, just going to automatically click through those. So anything that's a continuous x variable, JMP is going to make a linear regression display. And anything that's a categorical variable, well, JMP's going to sort of do this comparative, in this case, dot plot with the mean and confidence interval shown. Okay, so this kind of allows you to sort of just swap out. And in doing so, I probably starting to get a feel of some variables that might be related. You know, here meal time seems to be going up a little bit. You know, maybe there's some differences in some of these suppliers. Some don't look as strong. Kind of moving along here. Okay, this coating viscosity. And if I want to see some more statistics about these things I'm fitting here, I can choose to do that. So for example, I'm going to put the R squared up there. I'm going to put the equation. So you see up here in the upper left, I added the R squared and the equation. Okay, so as I click through these, I might look at that together. Oh, here's one that looks like it has a strong relationship. Okay. So I'm doing this sort of this one at a time approach just because I want to get a feel for it graphically. And again, I can choose if I want to save it to the data table, and I've already done that, so I'm just going to close it. And so I've got it right here. So again, whenever I want to see it, I just click the green triangle, and there's my graph. So now let's get into maybe some more formal analyses that are going to give us some more output. So i.e. regression and ANOVA output, even though we got a little bit of that in the graph. But JMP has a specific platform called fit y by x. Okay, so I'm going to launch that. Okay, so JMP's asking you, okay, put the y variable, the outcome variable in the response right there. And I'm going to grab all of the predictor variables. And, oh, actually, you know what? I'm going to do one at a time again. So I'm going to just put one there. Now, if I put them all there, what JMP's going to do there is it's not going to run a multiple linear regression. That's in a different platform that I'm going to show you next. It's just going to run one at a time. But instead of putting them all in, I'm going to do it this way, and you'll see why in a second. So I'm going to run this. Okay. Now, AD particle size is a categorical variable, large, medium, and small. So what JMP is setting up is to do a one-way ANOVA. So if I click on this red triangle, then what you're going to see is all these options that make sense that you would do in a one-way ANOVA when you got a categorical variable. So I'm going to click on this one here called means ANOVA. And then what JMP is going to do is going to add that standard output that you would see in a one-way ANOVA, right? The ANOVA table, you know, some hypothesis tests for this. I can even do multiple comparisons if I want. So I'm going to go up here and I'm going to do multiple comparisons, and then I will get another table down here, okay, showing me the comparisons and putting in the order of, you know, most significant to least significant. And you might have noticed there's all these little gray triangles here. This is what just allows you to expand and collapse little pieces of output. So if you're just trying to keep your screen a little clean and only show certain pieces of output, which is nice for teaching because sometimes you don't want all of those metrics displayed. You just want the students focusing, say, on the ANOVA table. So you can kind of close it all up, and I think it just makes it easier to interpret. Now, just like I did in the graph, I can actually bring up that same column switcher, swap out particle size, and now what I'm going to do is I'm going to put in all of the categorical variables. In here and hit OK. And just like in the graph, what I'm allowed to do is I can just swap out what categorical variable is being used. And I think this is nice not only for exploring data, but I think this is nice for teaching because you can swap around, look at all that output changing as a way to look for things that are most significant to least significant. We can kind of click through and we see that sugar supply, that one there is a low p-value. I think that was probably, yep, that one looks like the lowest. Okay. Now I'm going to bring up that same platform, that y by x again. But this time what I'm going to do is I'm going to build this for all of the continuous variables. Okay. We'll just move this over here. Now this is going to be linear regression. So when I drop the red triangle down here, the options are different than when I drop the red triangle here, because these options are going to be things you would do with a categorical X, and these are the options you would do with a continuous X. So I'm going to choose fit line, and jump adds the output, and some of it is similar to when you have a categorical X, but the output related to doing a linear regression. In this case, a simple linear regression, which is meal time. You see the equation, for example, right here. You got R squared. Okay. Now, just like I did in the categorical platform, I am going to pull up the column switcher, swap out meal time, and I'm going to do that same thing, but here I'm only going to pick all of the continuous variables. Hit OK. And so now we're on the right. I can do the same thing where I can swap out what variable is on the x-axis and watch the output change, and then look for, say, significant results or insignificant results. Again, really nice way to explore the data, but I think it's fun for teaching because you can swap things out and show students, hey, see how that's changing or not changing? Now, here's another really cool thing I'm going to show you. I'm going to pull up this other thing called the data filter. And what I'm going to do is just going to take a second here. I'm going to actually put in, oops, let me change that. Okay, I'm actually going to put in all of the categorical variables, okay? And make sure I get the numbers here. You might be like, why are you doing this? Well, you'll see in a second. Okay. All right. So now I'm going to slide this over just so it's a little bit bigger on the screen. Okay. So now what have I done? Okay. Well, I've got this thing over here called the column switcher. Okay. That's what allows me to change whatever I'm seeing on the x-axis. And then over here in the middle, I've got this thing called the data filter. That's what's going to allow me to filter this data so I only look at a subset of the data. So for example, let's say I wanted to look at the relationship between disillusion and meal time, but I only want to do so for the large particle size. Well, then I just click on large particle size. There's 29 values that are in the large particle size. And now the data in the graph, as well as all of this output, has changed. So it's showing me the relationship between disillusion and meal time, but only for the large particle size group, okay? And I can do any kind of combination, right? So I could say, well, how about medium and small, using sour for the sugar supplier and compressor 2, okay? Let me actually drag these over a little bit just so I can make this a little bit bigger so you can see the names, okay? So what I have done is I have chosen to subset the data by a different set of these categorical variables, like small and medium particle size, sugar supplier sour, and compressor 2, and I've got meal time on the x-axis, and I can look at all of this output, okay? And again, I can change what's on the x-axis, so I can change out every variable on the x-axis by some, and have the data subset by some way. Now, I can't emphasize this enough. I think it's a great way to analyze data because that's how you do it in real life, right? It's dynamic, it's interactive, you're playing with it, watching it change. But what a great way for teaching, right? Because now you can sit here and you can select different groups, right? You can select different groups and show some effect you're trying to show to your students, right? So I've got them all selected right there. So, for example, you can say, what if I take out I only look at the medium group. What's the relationship there? If I switch to small, is that relationship changing a little bit? And I can look, for example, look at this p-value. It's 0.07 when I'm in the medium particle size. But when I go to the small particle size, the p-value becomes very small, 0.0002. So what a great way to teach, because you can sit there and start swapping things out to show your students to illustrate some effect that's going on, as opposed to having to go back to the platform, run the output, and then go back to the platform, run the output again. And keep on doing that for every combination. So think of it, I got 10 different X's sitting here, and I've got all these categorical variables that I can subset the data by, okay? Now I can do the same thing. I'm gonna close this because I already have this saved. I can do the same thing. I've got this saved already. I've got this for the categorical variables on the x-axis. And again, I can swap them out, watching all the output change, depending on which one I want to use. And over here in the middle, I set up the local data filter, so it's all the continuous variables. So I'm sort of just showing this to illustrate that I can even filter the data by something continuous. So for example, I could say, what is the relationship between dissolution and particle size for mil times less than 20? And I can just select that, and now all of the output, all of the graphs have changed to show me that relationship between dissolution and particle size only for this group of data, this 56 rows that match this condition. And this stuff is interactive. It's not just I have to type in a number. Watch how that's happening in real time as I'm dragging these variables over. So again, it's a really great way to illustrate something to students where you can sit there and say, let me show you a condition where maybe the results are highly significant and some conditions where they're not. It's just a really great way, I think, to teach, because I feel like I learned when I was a student, and I felt that the best way to teach when I was teaching was to change something in the data and then to watch what does or doesn't change in the output. And I think JMP is set up for that, because when you run an analysis, don't think of it as a static piece of output sitting on the screen. You know, you run a regression or you run an ANOVA and you got this static piece of output. You're launching a platform. You're launching the regression platform. You're launching the ANOVA platform. And then that platform is live. It's interactive. It's dynamic. Now I can start playing with it, swapping variables out, filtering data as a way to explore the data or to illustrate to students some concept I'm trying to teach them. Now, again, this is all one variable at a time. So I'm going to have to show you another platform if we want to build a linear model that has all of these as potential variables. But I just think that's great. I don't think any stat software does it like this, with this concept of swapping out the variable and entering the data. This makes it an excellent tool for teaching. Okay, so now let's expand this to a multiple linear regression. And what I'm going to do here, hold on one second, I just want to find something. All right, yeah, I think I'm good to go. All right, so now what I'm going to do is, hold on one second, is I'm going to launch this platform called Fit Model. So I'm going to click on Fit Model. Okay, so this is where I'm going to do a multiple variable linear model. So I'm going to put dissolution in the Y, and I'm going to put all of the X's as the candidate predictor variables. Oh, this is nice. Everywhere in JMP, you kind of resize things, which is cool, because if you want to see the long list or, variable, names are long, you can kind of drag all this stuff around. So I think that's kind of fun. Now, if I hit run right here, it's going to fit a linear regression with all of the variables in there. So I'm just going to do that first. Okay. So here's the output of a linear regression with every variable. And one thing you can do with JMP is I can actually reduce or build up the model right from this output. Remember, it's not static output. We launched a platform. So let's say I was teaching the concept of reducing a model to my students. I can sit here and say, okay, here is all the variables from the most significant to the least significant. And I can say, okay, coding supplier is not significant. And I can select it and then say remove. And when I do that, watch all the output change. Okay, so everything has changed to say, okay, now I've got a model with only 16 predictor variables. And I can keep on doing that. So I can pull out this pressure, and I can pull out sugar supplier. So this is, and I can add them back in if I want, right? So if I want to go back, and again, a nice way to teach, because you can sort of watch the output and results change. Like, for example, I could focus on R squared, and if I pull out a variable that isn't significant, you're not going to see the R squared move a lot. But if I pull out a variable that is significant, so we're about 70% right there, I'm plus screen size, that's the most significant variable. Look how much we saw the R squared change. So again, a great way to sort of dynamically show concept by swapping things out, in this case, the variables in the model, and illustrating to your students how the output changes. And if I had graphs up here, they would all be changing as well. Now, instead of building it this way, what I'm going to do instead, I'm going to launch that platform again. But this time, what I'm going to do is I'm going to build a model through JMP's stepwise routine. So I'm going to launch stepwise. And when I hit run, and for those of you who are not familiar with stepwise, stepwise is just sort of an automated way to do what I was just doing manually a moment ago. So I can choose how to build a model, either by bringing in variables in a forward way, that is, find the most significant variable, put that in first, and then the next most significant variable, put that in second, and then having some criteria to stop. I can do it backwards, starting off with the full model and removing things that are not significant, which is what we were doing manually a moment ago. So I'm going to choose that method. And the criteria I'm going to use is a p-value. So I'm going to leave it kind of as the default here. So it's going, you'll see in a moment, I'm going to build this model. Now I can do it step by step if I want, but I'm just going to hit go. Oh wait, actually, sorry, let me do this mixed routine. Sorry, I'm going to go. Let me change some of these. I'm going to make it a little stricter to get in here and leave the model 0.10. So I'm just changing the criteria for the p-value of what's going to make a term enter the model, what's going to make a term leave the model. Now I can go one by one. I'm just going to hit go and let JMP run through that algorithm. Okay, so it automatically went through that procedure by including variables that it considers significant and excluding variables that it considers insignificant. And here is the selection: middle time, screen size. And I can actually choose to put them in or not. So here's another place where I can watch results change. See here, for example, here's the R-squared. I can show the students how those R-squareds are changing when I put in or take out a significant variable, and something that isn't significant. I'm clicking on inlet temperature. You'll notice the R-squared is not moving that much. So this allows me to even force terms in or take terms out. Okay. Now I'm going to say make model. It's going to bring me back to the dialog box to run a regression, but in this case, it's only including the variables that were determined important from that stepwise routine that I ran. Okay, so when I hit run now you're only going to see we have 7 variables that it considers to be important, and those are shown right there. And you'll notice all of them have a p-value of less than 0.10 because that was the criteria. You can see this blend speed just creeped in there at the end. Okay. Now I can start picking different pieces of output I want to see. So right now I just have this minimal kind of display of output. If I drop down the red triangle, now I have all these options. So for example, I could choose to show some diagnostic plots. Here's plotting the actual versus predicted. I can do residual graphs. I can save in like the predicted values and the residuals and the confidence interval and all those things you're used to dealing with. This is where I would choose to save them. I can show, for example, the equation. I can do testing. I can do some comparisons. I can do some contrast tests. I can make some graphs. Now, I'm going to just close this because I already did this and pulled all the things down I want and saved it. So I'm going to close that up and bring up this. And what I did is all of those things I was showing you, I picked a bunch of them already. Okay. So for example, this graph right here at the top, this is plotting the actual dissolution values of those 90 observations on the y-axis and the predicted value on the x-axis. Now those should follow, a straight line because it's kind of a measure of how well I'm predicting, right? So I should see a strong correlation there. I got a residual graph here. I'm showing that. Oh, you probably noticed this. All of the values that meet the criteria of having a dissolution above 70, I colored them green over here. And all the ones that don't meet that criteria, I colored them red. So then every time I make a graph, I see that. And I did that by just kind of selecting where, see, I can color the variable. So that's why I said accept is green and reject is red. I can turn that off if I want, but for this example, I think that's nice to see those points like that. Okay. So I'm just going to scroll down. So these are things I've added. So here's the equation. So here's the regression equation that was built. Okay, so I can choose to display that. I can also, like I showed you before, I can kind of collapse some of these things if I just want to make the output a little bit smaller, right? I can choose to hide. And again, this I think is fun for teaching because then when showing your students something in class, you can actually just focus on a specific piece of output. So for example, if I just wanted to show, you know, the R squared and summary of fit, I can just display that if I want. Okay, or close it. Now I've got my classic residual plot with on a normal probability plot, just to sort of evaluate that assumption. Used to that, I'm sure if you're teaching students those checking of assumptions. Another thing I had displayed is something called the prediction profiler. So now it's showing those coefficients and looking at each of the variables sort of one at a time. So this first one here, this is mill time, and then this next one here is screen size and blend time and blend speed, and I can start moving these around. Okay, and over here on the left is my prediction with a confidence interval around it. So I can sort of move this to find different settings of these variables and decide how they, or illustrate, I should say, how they impact the outcome. So blend time, that was a big, spray rate, that was a big one. That's what I'm looking at right here. And I can see the prediction. I can also display that if I want on a contour plot. So here's a contour plot of two of the variables, screen size versus mill time, and I can swap them out, just drop the red triangle. So if I want to look at a different contour plot, and I can choose all sorts of things like what the contours are drawn on. If I, for example, have a region, you know, like sort of this optimal region, I can define those zones if I want. I've got here a circus plot. So I'm plotting mill time versus screen size here, and I can kind of rotate that around to show the effect. And I can swap out, you know, if I want to see, I'm swapping out mill time to blend time and rotate that around and see it. And then I can move these variables too. So now I'm seeing, well, how is that surface, you know, moving up and down if I move around another significant variable, right? So again, a nice way to illustrate concepts. Okay, and again, I can close that if I want. Now, I'm going to show, I'm just looking at the time, trying to make sure I get to all the things that I want to show. I'm actually going to, I'll pause on that. I won't show that. Okay, so the key that I hope you got from this is you make graphs by launching this thing called the Graph Builder, and that's what allows you to sort of build graphs in sort of this blank canvas, putting in variables, choosing how you want it displayed, swapping out the variables if you want. Okay, I could have also filtered the data by there too. I showed you the Y by X platform, so you could do this for a continuous variable or for a categorical variable. Let me get them both up there. Oops. All right, so I've got one of these panels is showing the continuous variable on the x-axis. I can swap them out, all the output changes, and then I can choose to filter the data by any of these variables that I've added. In this case, I chose all the categorical variables, and I can kind of, again, pick little conditions that variables I just want to see. I'm kind of, at this point, I'm selecting it to the point where there's very little bit of data. Okay, and then over here, I did the same thing, but I'm showing you that you can actually include a continuous variable as a filter, and I can slide it around and pick different conditions that I want to filter the data by and see how all the output changes. Okay, but again, those are one at a time, you know, one X at a time. If you want to build a multiple linear model, then you launch this platform called Fit Model, and that's where you include the variables you want to include. And so the last time I ran it, I only included the 7 variables that were shown to be significant from doing a stepwise first. And then, as I showed you, you can start selecting different output you want to see, whether it's residual graphs, whether it's the equation, whether it's profile or contour or surface plots. you just select those by going under the red triangle and picking the things you want to see. And right from here, I could choose that filter data thing if I want to, right? I could pull up that local data filter, and I'm going to actually just do this to illustrate something. So I'm going to say, for example, I'm going to pull up just one of these guys, sugar supplier, and I can click how does this output change for the sour sugar supplier and how does it change for the sweet sugar supplier. See how all the output is changing, right? So again, a great way to analyze data, but I think even a better way to teach, because you can show the students, illustrate to the students, watch how things are changing or not changing as I do something else over here with the data. Okay, close all these guys up. All right, and the next one I'm going to show you is I am going to launch a data set to show you the partition platform. Now this is a neat little data set here. This happens to be a collection of over 8,124 mushrooms. Okay, and so each row is a mushroom, and the mushroom is defined as being either poisonous or edible. And then I've got all these characteristics about those mushrooms. So this first variable is the shape, right? Actually, let me hit that little histogram up there so we can get a better sense of what's there, right? So I've got edible and poison, so it's about half and half, okay? Then I can see I've got different shapes, cap shape, convex, flat, knob, bell. And you see, as I'm selecting these, they're highlighted in the data table, which lets me filter the data right from this point if I want. And you see how many different variables I have. Things about the cap, color, the odor, what the gills of the mushroom look like, the shape of the stalk, their color variables. So you can see this whole list. There's 22 total variables. Okay. Now they're all categorical. Okay. So you got to think, well, I would find the ones that are best at guessing or predicting if the mushroom is edible or not. Now, this is a good example to use a technique called partition, and I'm going to launch this platform. Oh, actually, before I do, let me just pull up the distribution, showing all these bar charts and counts and frequencies. And again, remember, I can click on these, and in doing so, I can sort of see, which characteristics are correspond to being poisonous or edible. I can go the other way. So, for example, I can click some of these and see how is edible and poison changing as I move around and select different subsets of that data. Okay. All right, but I'm going to close this up because I want to determine this not from just clicking around. That's kind of hard to do with 22 candidate explanatory variables. So I'm going to launch this Boolean jump called partition. Okay, so I'm going to put the outcome variable, whether the mushroom is edible or poisonous, and I'm going to put in all the 22 candidate X variables. Okay, and I'm going to hit OK. And so the first thing JMP does is just, well, I'm just going to show you the data in terms of the number of ones that are, going to add this so I can see that information. So it turns out that there is about 52% of all these mushrooms are edible and about 48% are poisonous. So that's just kind of showing you the data, and it's coloring it green or red as I did with the other examples. I think that's a nice way to see the data. Okay, now we're just randomly spreading this data around in this box just to kind of fill the space up, but this is just showing me that it's about 50-50. Now, when I hit this button split, okay, when I hit this button split, what JMP is going to do is it's going to find the variable, okay, what variable that if I split it by will cause the biggest difference in the percentage of edible mushrooms to poisonous mushrooms. So I'm going to just hit the split button once. And what JMP will do is it sort of makes this little tree diagram. And so what it did is, now it searched through all 22 variables. It looked through every combination, and it came back and said odor. This variable called odor, if you split by this breaking it down by, if the odor is none, almond, or anise in its odor, then 97% of those, so there's a total of 4,328 that have that characteristic, 4,208 of them. In other words, 97% of them are edible, and 120 of them, or about 3%, are poisonous. For the odor in the other direction, where it has this creosote, foul, musty, pungent, spicy, or fishy, of those, there's 3,796 mushrooms that have those odors. It turns out all of them, all 3,796 are poisonous, okay? So search through every possible breakdown of those 22 variables and found out that split right there by that grouping of odor is what caused the biggest difference between those mushrooms that are poisonous and those that are not. And so up here in this top diagram, it created these two panels, those two odors, and it shows you can see, if I look on the right side, you can see all those that are edible, and there's a little bit there that are poisonous. And that line is drawn right there, that 97%. Okay. Now I can keep on growing this tree. I'm going to hit split one more time. Okay. And when I do that, I have to scroll down so you can see it. So it's taken the 4,328 mushrooms that have this non-almond or anise odor, and the next variable it's found, again, search through all these 22 variables across these two groupings of odor, and found out that if you split by this thing called spore print color, and it's either green or it's white, buff, chocolate, black, brown, orange, purple, or yellow, if you split by that, it turns out that there are 72 mushrooms that have a non-almond anise odor and have a spore print color of green. There's 72 of them, and all 72 of them are poisonous, okay? All 72 of them are poisonous, okay? That's very interesting because now it went into this non-almond and anise odor and went into that 120 and pulled out a bunch of those ones that are poisonous, okay? Very helpful. Now, the other spore print color, which is this set of white, buff, chocolate, etc., there are 4,256 in that grouping, and of those, 4,208, or basically 99% of them, are edible, and 48% of them are poisonous, okay? And then I can keep on splitting if I want. So it's going to go and search through and find another variable. So now what did it do? I'm going to scroll down to see it. So now it went inside of this particular spore print color, this particular odor, non-almond or anise, this particular grouping of spore print, and it broke down by this other variable called stock color, okay, below the ring. So it's either yellow or brown, or it's white, red, gray, orange, or pink. Again, it went in there and found out that if you cut the data that way, then you created the biggest discrepancy in being edible or poisonous. So if you look over here on the right, you'll see that in that group, there's 4,152 mushrooms, and almost all of them, over 99% of them are edible, and there's only a very, very small percent, there's 8 mushrooms in that group that are poisonous. Okay. Now I can keep on splitting, and eventually I could actually split this thing down to the point where there's only one mushroom in every final little leaf, they call it. That would be overkill. That kind of has the tendency to overfit. So JMP has actually this routine. I'm going to close this up. JMP has this routine where what I'm going to do is I'm going to make this column, and I don't know if you are all familiar with this concept, but I'm going to make this column called the validation column. And what I'm going to do is at the very end, I've just added this column called validation. Half of the data is going to called the training data set, and half of the data is the validation data set. So why that's useful is I can now tell JMP to build this partition model, okay? Build this partition model, but I want you to only build it on half the data, the training data. And as you build the model, I want to see how well that model does at predicting the validation data, which is data that isn't a part of the model building process. And so by setting it up this way, instead of me manually splitting one by one, I can actually just hit this go button And jump is going to keep on splitting. And when it maximizes the R squared for the validation data set, it's actually going to stop. Let me just add, I want to just show this here. When I hit go, it's going to go through all those splits and it's going to stop automatically for me when it says, hey, I can't split anymore to improve your predictive ability on the validation data set. Okay, so it's going to make that classification error as small as possible. So I'm going to hit go. And it happened really fast, but I'm going to show you what the tree looks like by just making the screen a little bit bigger. Okay, and here it is. Actually, you know what? Let me show you this. There's another little way I can show a small tree view. I'm doing this because it's a little bit easier to see, as opposed to having to scroll through this bigger diagram. Though there's all the counts and information that I want, but now you see how it's splitting. So this is interesting. You'll see that this first split that was by that odor, it never split that group over on the left ever again. So remember this group right here? It never split that again. All the splitting came in this odor, none, almond, or anise. And this diagram shows how it split. So the next variable was this gill size color. Then there was the stock surface, and this population variable. So it's kind of showing me how it split, and it stopped it. And if I actually go to these bottom leaves, you'll see that it's found groups where all of the mushrooms in that particular grouping are all 100% poisonous or 100% edible, right? So if you picked up a mushroom, you would go through this. So you would start off with, what's its odor? You would pick something, and if it's, say, almond, you go, okay, now what's its spore color? And you're like, well, it's orange. Okay, you move through. And then you're like, okay, what's the gill size? And you're like, okay, narrow. You move down the next thing. And you're like, okay, what's the stalk surface? Okay, it's smooth. You'd go down to the next group. And then does it grow in clusters or does it grow solitary? So solitary, and you'd be like, okay, it grows by itself. It's solitary. I'm down here. There's 148 mushrooms that fit this category in the training data set, and all of them are edible. So if you wanted to take your chances and you found one of those mushrooms in your yard, I'm not advising you to taste it, no matter how well the model does. It's a bad idea. My wife always gets mad at me because I like walking around tasting plants as we go on hikes and stuff. But I do avoid tasting any of the mushrooms. But I do like tasting little leaves. I'm in California, so there's a lot of fun things that grow wild, like fennel plants and such. Okay. Now, what I want to finish it off with is jump to a lot of these really neat interactive teaching tools that I'm going to open up to show you. And I'm going to grab one of these here, teaching scripts. I'm going to grab these interactive teaching tools. So I grabbed this under the help menu. So if I go under the help menu and I go sample data, now in here is all these sample data sets that we have that you can use to illustrate a concept. So if you're like, hey, I want some examples on consumer research, then we have a bunch of data sets that fit that kind of application. Or if you're looking for a specific statistical tool, you can pick that way. But I'm not here to show you a data set. Instead, I'm going to launch one of these interactive teaching tools. And so I'm going to launch this one for regression. Okay. And so this is a way that you can teach to your students or have your students sort of do themselves to illustrate a concept. Okay? So basically what's happening here is you create a population data set, right? One that has a particular linear relationship, one that has a particular correlation. So I can specify that, right? I'm over here just choosing what I want to illustrate, right? I want to have low correlation or high correlation. And then over here on the right is going to be a sample data set drawn from that population, okay? Now, you can have the students, for example, say, hey, you go and you fit a line through that data that you think is the best fit to that data. And I can move this around. Now, over here on the right, those are showing me the residuals. Okay, so I can kind of go through here and I can fit a line that I think is the best fit to the data. And then if I want to see how well I did, I can then say, well, show me the least squares line, okay? And then I see the least squares line, and then I can compare the residuals and the R squared from my fit to the least squares fit. And then down on this table, it's showing me the particular least squares line for that particular sample of data, and the black line there is the true regression line that I specified over here in these population characteristics. Now, I can keep on doing this over and over, and I'm drawing random samples of size, in this case 25, but I can change that. And doing it over and over again, and in each case, it's fitting a regression line. And I'm going to get rid of my line here. Fit my line, let me get that off the graph. So it's fitting a regression line using least squares for every sample of data. And this graph right here is showing me each of those fitted lines. Now, notice what concept I'm able to illustrate here to show the students. I'm actually illustrating how the confidence interval for fitting a regression line is narrow in the middle and widest on the edges, right? And I can see that happening. Now, there's all sorts of things I can show there. So, for example, let's say you were teaching the concept of a sampling distribution for, say, the beta 1, the intercept. Sorry, the slope. I can sit here. Now, I've already done a bunch of samples. That's why the graph is already there. But if I say, let me do, I'm going to restart the demo. If I do it from the beginning here, I'm going to open that up. I'm going to choose the slope. And so as I draw a sample, it's showing me the slopes I'm getting. I can watch and illustrate that concept of what is a sampling distribution. Okay? Now, I showed you the regression interactive tool. Oh, one more thing. Let me pull that one thing up again. The other thing you can do with this, if you're showing this, is I can actually add data. So I'm going to put a point right there on the edge. And so now if I want to teach the students the concept of influence, I can say, hey, look, a data point on the far left that's very low, look how much I can change that regression line. But if I move this data point to the middle and move it up and down, look at that. The regression line is barely changing. The slope is staying about the same, right? So this is a great way to teach this idea of influence on a regression equation. Okay, so I find it really fun for teaching. Now, I just showed you the regression, but you see we have a whole collection. We have one for ANOVA. We have one for the hypothesis test, illustrating confidence intervals. And each of these are these interactive dynamic simulation tools, so you can help teach the concepts. Okay, I'm going to close that up. And then what I'll do just to finish it up, and then just to make sure that that we have some time for some questions, I'm going to just go to the JMP website because I want to show you where some of these resources are. So if you go to the JMP website under JMP in Action, we have a section called Academic. I'm going to click on that. And in here is a collection of all sorts of resources that we have available to you. So the webinars that we're doing right here, these live webinars, we actually have a whole library of ones. So this one may get recorded and placed up here, but you can go and see previous recorded webinars here. We also have little quick instructional videos and these things we call one-page guides. So if you, for example, are teaching linear regression and you want to just point your students to a little instructional guide that's so they know how to run a simple linear regression, you can just point them to this little instructional tool, shows them how to do it, or you can go and watch this quick little video. So this way you don't have to spend time in class trying to show all that, like how you're using JMP. You can just point them to these resources so they can watch them themselves. We also have these case studies, which is the collection of data sets and storylines that that you can assign to the students as project or homework assignments. We also have course materials. So we've got lecture notes that you can use. We've got a whole collection of books and manuals. So there's a whole bunch of resources here, those interactive learning tools that I was just showing you. So we have a whole bunch of resources for you, so you don't have to be on your own trying to provide instructional guides to the students. We have them for you. That's particularly valuable now because we know all of you have been thrown in this situation where you have to start creating all these online materials because you've all had to transition to this during this sort of shelter in place with the schools, on-site schools closed. So take a look at these learning resources. You're going to find some videos, some tutorials, materials that could help you during the end of this semester here while you're having to do all of this out of the classroom and online.